Hello again, Year 10. It's Mr. Green here, taking you through Lesson 2 of the Year 10 Physics unit, and this is electricity. Focus stay on charge and current, and our learning objective is to describe the current flowing in a circuit. Please pause the video and write that down as your title for today's lesson. Okay, our retrieval for the start of this lesson, and name those 5 symbols. So pause the video, copy the symbols out, and then name them afterwards. You can pause it now. Okay, these 5 symbols are: first one is a bulb, second one is a resistor, third one is a cell, fourth is a battery, that's a number of cells joined together, and fifth, a voltmeter. Okay, our learning outcomes for today are to define potential difference, define an electrical current, and explain why an electric current will flow in a circuit. Our first thing, what causes this lamp to light? We've got a battery, we've got copper wire that's linked up to a bulb. What causes the lamp to light up? Have a little discussion with the person next to you. Okay, the lamp lights because there's electricity flowing from the battery to the bulb. But what is electricity? Electric current, which is flowing through that bulb, is a flow of a charge. So any particle that's got a charge flowing through there would be electricity. As we've set it up there, those charged particles would be called electrons, and they carry a charge, a negative charge. So they would push from the battery through the bulb to the wire. Each electron contains an amount of energy that it's being pushed with. That is called the voltage. And what we measure is what the voltage before it enters the bulb and after it enters the bulb. That gives us what's called the potential difference of that bulb, telling us how much energy is used by each electron passing through the bulb. So electric current, the size of the electric current is the rate of flow of electrical charge, so how quickly electrical charge is flowing, and we measure this in amperes. Electrons are negatively charged particles, and they transfer energy through the wires as electricity. Charge can't really be defined. Charge is not something that's separate, it's something that's owned by something or something displays. So charge is a property of a body, and that experiences a force in an electric field. Charge is measured in the unit coulombs, which is capital C. 1 coulomb of charge is a package equivalent to 6.25 trillion electrons. So that's a huge amount of electrons. As you can imagine, they're absolutely tiny. If you could pause the video to make sure you've got all those points down in your book, please. Okay, current is measured using an ammeter, and that's placed in series, which means next to, on the same loop as the component you're interested in. So in this case, the ammeter is in series with the lamp. So all the electric current will flow through the amp and the lamp. Potential difference is different. It's a measure of how much energy is transferred between 2 points in the circuit. We always connect a voltmeter in parallel with the component we want to measure. So we would place one wire to one side of it, one wire to the other side, link that to the voltmeter, and that tells us the difference between the energy of each electron going in and coming out, so we can see how much has been used. Okay, so match the following sentence starters with the correct definitions. If you could pause the video, start 3 sentences: current is, potential differences, and charges. Then you've got 3 choices there of how to finish your answer. Give you 2 minutes or so to do that. If you could pause the video. Okay, so to go through these answers. So first one, current is the rate of flow of electric charge, or the rate of flow of electrons in a circuit. It's measured in amperes or amps. Potential difference is a measure of how much energy is transferred between 2 points in a circuit, and that's measured in volts. Charge is a property of a body which experiences a force in an electric field, and we measure that in coulombs. So how can we model electric circuits? Well, the point of a model, what's the point of it? Is to try and visualize it in a slightly different way so we can work out what's happening a little easier. So in this model, we have a pizzeria, we have a restaurant where people will be eating them, and we have little mopeds carrying them around. So in this case, the moped riders represent the flow of charge, or the electrons that are moving around that circuit. The pizzas represent the electrical energy carried around the circuit. So what would the pizza shop and the house party represent? The pizza shop represents the battery, or the cell. As the mopeds arrive there, they're given energy. They're given the pizzas, which are the electrical energy. They're then carried around the circuit until it gets to the bulb. The bulb, or the component, would be the house party. Once they arrive there, they pass that energy on to the members of the house party, and when they leave that house party, they have no pizza left to carry around the circuit. So you can see on the right hand side of the circuit, all the moped drivers have pizzas, they have energy to pass on. On the left hand side, all the moped drivers have no pizzas, they have no energy to pass on. When they pass through the pizzeria or the cell, they pick up pizzas or energy again. So in this case, if we realise, or if we change the moped drivers for electrons, the pizzas for electrical charge, and the house party for a battery, we can see how an electric circuit works. Now, as this is physics, we have some equations that we need to learn. Our first equation we need to learn is this. Charge flow, current and time are linked by the following equation. Charge flow is equal to current times time, or Q equals IT. You need to get that down. You need to be able to draw it in an equation or a triangle so you can rearrange it, and you need to make sure you have those units. So if you could pause the video and copy that down for me, please. Okay, so we'll do two examples and then I'll ask you to do the questions. So what's the charge when a current of 5 amps flows for 60 seconds? So if charge flow is current times time, then our current in this case is 5, and our time is 60 seconds. 5 times 60 gives us 300 coulombs. Okay, try the next one yourselves. Pause the video and try the next one. What's the charge when a current of 4 amps flows for 35 seconds? Pause now. Okay, we use the same equation. Charge is current times time. Current in this case is 4, and time is 35 seconds. So 4 times 35 gives us 140 coulombs. Make sure you put your unit at the end of that. This next part we have to rearrange our equations, so make sure you've got your equation triangle written. First question, what is the current when a charge of 960 coulombs flows for 2 minutes? Pause the video and attempt that question. Okay, charge is equal to current times time. We need to rearrange that. That rearranges to current is charge divided by time. Charge is 960, but time's been given in minutes. We need to change that into seconds. 2 minutes would be 120 seconds, so 960 over 120 gives us a current of 8 amp. Okay, next question. If a charge of 1500 coulombs flows for 5 amps, how long is the circuit switched on for? Pause the video, rearrange your equation, and calculate the answer. Okay, so if charge is current times time, we rearrange that so that time is charge divided by current. Charge in this case is 1500 and current is 5, so 1500 divided by 5 gives us a time of 300 seconds. Okay, 6 questions on the board for you there. So if you pause the video and attempt those questions, answers will come up after this. Okay, if you've attempted all those, we'll move on to the next slide, which shows you the answers to all those questions. Assess that in green pen. Mark what you've got right correct. If not, correct it with your green pen. Next, load of extension questions. So questions 1, 2, 3, 4 and 5. Pause the video and please attempt those questions. Okay, if we've started up again, the next slide will give us the answer to those extension questions. Okay, and that's it for today's lesson. To continue on, there will be a series of exam questions. Just pause, attempt the question, move on for the answer. Okay, next slide will be the answer. Again, pause to make sure you have that correct. Thanks very much, Year 10. I'll be back to see you with our next lesson. See you again soon. Goodbye.